A binomial model tells us the probability for a random variable that counts the number of successes in a fixed number of Bernoulli trials. Two parameters define the binomial model: n, the number of trials, and p, the probability of success. So in n trials, there are a combination of n choose k, so that is equal to n factorial over k factorial times n minus k factorial. So we read this nck as n choose k, and you'll also see it written as a fraction, but there is no divided by sign. Note, n factorial is equal to n times n minus 1 times so on all the way down to 1. We have n equals the number of trials, p equals the probability of success, q equals 1 minus p, which is the probability of failure, and x is the number of successes in n trials. So the probability that we get x number of successes in n trials is equal to the combination of n choose k times p to the x power q to the n minus x power. Now for the mean, it is equal to n times p, and the standard deviation is equal to square root of npq. Suppose that 10% of people are left-handed. If 8 people are randomly selected, what is the probability that exactly 2 of them are left-handed? So we're looking for the probability of 2 successes out of 8 trials. So we have 8 choose 2 times p, which is the probability of success, 0.1, to the second power, and q, which is the probability of failure, 0.9, to the 8 minus 2 power. Plugging this into the calculator, we get 0.1488. So to do this in the calculator, we're going to go to second vars, and we're going to scroll down until we get to binomial PDF. We're going to type in 8 for the number of trials. Our probability of success is 0.1, and we're looking for 2 successes. And there's our answer. Find the probability of at least 2 girls in 8 births. Assume that male and female births are equally likely and that the births are independent events. So we're looking for at least 2 girls in 8 births. So that means that we could have 2 successes, 3, 4, 5, 6, 7, or 8. So we're looking at 8 choose 2. Since they're equally likely, we have a probability of success of 0.5 to the second power. Failure is 0.5 to the 8 minus 2 power. That'll give me the probability of 2 successes, or 2 girls in 8 births. And we're going to do this for 3, 4, 5, 6, 7, and 8. So 8 choose 8, 0.5 to the 8, 0.5 to the 0. And our answer is 0.965. Notice you do not need to write this whole thing out. If you can give me the first and the last one with some dots in between, that'll work as well. Another way you could do this is to do the probability of 0 and 1 success and subtract that from 1. Now on the calculator, we're going to do this as second vars. We're going to go to binomial CDF. We're going to type in 8 for our number of trials, 0.5 for our success, and we're going to type in 1. And the reason we're going to type in 1 is because the binomial CDF adds up all the successes from 0 to whatever this last number is. So our answer is 0.035. Now, what we're going to do is we're going to subtract this from 1. And there's our answer, 0.965.